Okay, lesson 2, horizontal and vertical translations. So this course in general, like this is probably like the most important, like the next like 3 lessons I'm going to do right now are probably going to be like the most important lessons for the entire course because that so much of it is we just do these things for different types of functions. So like we have a radical functions unit, we have a polynomial functions unit, and like a big part of each of those units is translating those graphs sideways, stretching them, reflecting them, right? So if you guys were ever going to put your full attention into something, the whole course is going to get so much easier if you do really well on lessons 2, 3, and 4. Because like it's just going to come up just over and over again. So just really try to get these down. Okay, can you guys, if you have your formula sheet, can you grab it? I just want to show you a really important formula. Yep. You didn't get one? Okay. Yeah, on your formula sheet, right here, this general form of transformed functions, the most important formula on your formula sheet. You're going to have it memorized in no time anyway, but it probably doesn't make much sense yet. But what we're going to do really in the next 3 lessons here is we are going to piece this thing all together. We're going to figure out, you know, what this thing means just piece by piece. Okay, and then by the end of lesson 4, we can just use that general, or end of lesson 5, we can just use this to do anything we want. Okay, so starting out, what we're going to be focusing on for lesson 2 is just transforming it or translating it up and down and left and right. So what does that look like in the function? So just a couple of terms here. Whenever we move a graph from like the original function into a new one, we call the new one the image function. Okay. Okay, so vertical translation. So if we look at the graph y is equal to f of x, and remember when I say f of x, that just means like any general function. So that could be like x squared, that could be square root of x, that could be like any function I'm talking about. It's just generally called f of x if we're just saying like, you know, we're not giving a specific graph yet, we're just saying, you know, generally, okay? So comparing y is equal to f of x to, and then y minus k is equal to f of x, or y is equal to f of x plus k. All right, so I've got that little formula over here, right? And I just want you to know what we're talking about with a k is just this last part of the graph, or the last part of the equation, I mean. So we're just saying, like in this case, if we have y is equal to f of x plus some number, right? K could be like 1, 2, a million, whatever, right? Then if k ends up being, well, here, you know what? We'll figure this one out. So if we look at the graph y is equal to x squared, right? Just the general graph y is equal to x squared. I'll show you guys a little trick for graphing this without actually punching it into your calculator. So y is equal to x squared. If I threw 0 in for x, then what would I get out for y? 0, right? So I know this thing actually goes, it starts in the origin, right? And I also know from, you know, math 20-1 that this is a parabola, right? And I can also tell that, you know, it's positive out front, so it's going to be a smiley face. He's being positive, right? So this thing's going to open up. But the question is, like, by how much, right? And we can throw numbers in for x and see what we get out for y. So, for example, if I put in a value of 1 in for x, what would I get out for y? 1, right? So there's a point right there. If I threw in -1, what would I get out for y? -1 squared. 1, right? Positive 1, right? Where when you square a negative, you end up being positive. So this is starting to make sense, right? Now let's do 2. If I threw 2 in for x, what would I get out? 4, right? So that if x is 2, then y is 4, and then the same on this side. So there is your general x squared parabola. You gotta get good at just kind of doing, like you'll do it really quick. The pattern here, though, if you want to, I'll be doing this more often too, is you go over 1, up the odds. And what I mean by up the odds is I go over 1, up 1, over 1, up 3. The next one, if I had a bigger graph, would be over 1, up 5, over 1, up 7, right? So it's over 1, up the odds. So you can do that really quick when you're just sketching these things out. Okay, oh, why did I do that? Okay, so if we just kind of sketch that thing. Okay, then if we look over at what happens if I have x squared plus 1, and remember so x squared, that was my like function, right? That's my general function. It's like f of x. So if I go x squared plus 1, what's going to happen is that all of our values, right? Like this would have been, here, let's actually put in a number. If this was 0 to begin with, right? On the original function, what is it now that we added 1? What will y come out as? Yeah, oh, yeah, it will in this case. It still will be the y-intercept, right? And we've been used to that too, haven't we? That number on the end has always been the y-intercept, right? In this case, it will be again. But we can kind of see too, if, like I said, if we look at this point, right, the origin on the original, then that point was 0, and I'm just adding 1 to it, right? If I subtracted 1, then it would go down. And that's going to be the case for every point on this graph, right? So what we can do, so now what we can say is, well, okay, that point will now be there. And just so you see what's happening here, that point there, that's at 1, 1, right? The value of y there is 1. If I go, the function, so 1 plus another 1, what will that be at now? 1 plus 1, you guys got this? 2, right? So that's going to be 2. So that point would now be at 2. Well, I'll make that green. So that point would now be at 2. Okay, we can kind of see what's happening, right? So why that over 1 up the odds is helpful is because I could sketch this thing out really quick here too, is I can go, okay, over 1, up 1, over 1, up 3. And same on that side. So I can sketch that thing out really quick now. Okay, now it might be written in this form, right? Y minus 1 is equal to x squared. But we can do a little algebra in that, right? That really is the same thing. Y is equal to x squared plus 1. Right, just moving the 1 from the left side over to the right side. So that is just the same equation. Okay, go through the dots better than I did. Okay. I'm just going to do these ones quick. I kind of already jumped to the chase there. If I subtract 1, right, then all of my y values, every point on that graph, it'll all be down 1. So I can start here, do my little over 1 up the odds thing. So over 1, up 1, over 1, up 3. And then just it's like a mirror image on the other side. And then same with this one, right? Okay. That's going to be the main gist of this lesson. Is just going to be, well, those ones actually that we're going to go to horizontal translations as well. So those are called vertical translations. Quite often what I'm going to do is I'm going to write, something has like a vertical translation, so just VT of like 3 or something, right? And I'll just kind of do it in short form like that. Okay. Yeah, just careful when the K is on the other side. I typically like to just move it over to this side just to see what it's actually doing up and down, right? All right, horizontal translation. So now, let's sketch this one again quick. So y is equal to x squared. So start at the origin, over 1, up 1, over 1, up 3. Okay, so now, what happens? So if I had it written like this, right, so it's f of x translates to y is equal to f of, and then I've got x minus h, like inside the brackets, right, like inside of that. Remember what that is? Remember how in the last lesson we were going like, what is f of x plus 2, and then we had things, of x with the x squared, plus 4 or something. Do you remember what we did? We like actually replaced the x in the equation with x plus 2, right? So it's like the x plus 2 is what we're replacing the x with, right? So all the x values are getting replaced with x plus 2. Okay, so that's kind of what we're saying here. So instead of x squared, right, we're actually replacing the x with x plus 2. You see how those are like the same thing there? The function itself gets put like inside those brackets and then it's squared. Okay? So if it's written like that, then in this case, we'll actually have the same function, but it's going to be over to the left. It's actually going to start there. And then we can go over 1, up 1, over 1, up 3. Like this. Now, that's kind of the tricky thing about this, right? Is because this was a plus symbol on the x. So you might be thinking that it should have been translated to the right, like the last one was. But it's actually always going to, with the x's are always the tricky ones. The x ones are always the opposite of what you would think they would be. So if it's a positive, it's going to be translated to the left. Okay? And really, the reason for that, right, it's the same type of thing. You know, when we factored numbers and we'd have like x minus 2 and x plus 3 or something, remember how the x values are like the opposites of those signs, right? It's actually the same kind of thing here, right? So if you think about like what x would have to be right there in order to like turn this thing back into that point, like where it started, x would have to be -2, right? So that's why, right? It's going to be the opposite of those things. You can also think if I was going to solve this for x, right? If I have y is equal to, x plus 2 squared, and I was solving for x, you would take the square root, and then technically you'd have like plus or minus y. And then the very last step is I'd go x minus 2 to solve for x, right? Once I took that off. So you can think about it that way too if you were solving for x in that case. Yeah, either way, or just remember, it's the opposite of what you think when you're dealing with x's. Okay, so that's pretty much it. Just watch out for, like with the vertical translations, watch out for the minus k on that one. Oh yeah, sorry. If you're looking at this equation right now, that relates to your formula, right? On your formula sheet there. It's just a little simpler, but what we've done so far is we have figured out the h part of this equation, and we figured out the k part of this equation. And so far, like the a and the b would just be like 1. So they wouldn't have any value yet. The a and the b, those are going to be our stretches, like how the graph stretches when we get there. Okay. Now, you'll see words like indirectly and directly. So in the first formula, k is indirectly connected with the y value. What that means is it's on like the other side. So if it's indirectly, then the same mathematical operation is going to be applied. Like it'll be what you think it should be. If it's directly, so if k was on this side, like it is there, then it says that it's like directly, it's like with it, so it's directly connected to the y value. So then it's going to be the opposite. And then with the x value, or sorry, the h one, that's directly connected to the x, so it's going to be the opposite. That seems a little confusing. If you understood that, great. But if you want to just kind of go off of like that x is always like move this k over to this side, and it's always going to be what you think it is. And then your x value is always going to be the opposite of what you think it should be. Okay. All right. Mapping notation. So quite often we're going to be given a bunch of information. And it really helps to make like a rule for how every point on the original function is going to be translated into the image function, and that's called mapping notation. Okay, so let's just do some examples. Here's an example. So we're going to say any 2 points in the original graph are going to be transformed to either like x plus a number or minus a number, and y plus a number and minus a number. Okay, so give you an example of this. So it says a function is transformed 3 down and 5 right. Write the mapping notation for this translation. So what that's going to be is we're going to say, okay, any value on the original graph, so any point x, y, and then you're going to draw an arrow. So it's going to turn into, well, okay, so x, and x is going to be like your left and right, So I'm looking at the 5 there, and it's going to be 5 to the right, so that's going to be x plus 5. So whatever x was, it's going to be 5 to the right. Okay, and then comma, and then we'll put the y value. So then y, and every point is going to be 3 down, so it'll be minus 3. Okay, and then we can just, once we know this, like once we have this mapping notation figured out, it's kind of like a key to solve the question. Now, no matter what point I have in the original one, I can figure out what the new point will be. Okay, so and this comes, these ones aren't too bad when they're like, nice and easy, but once we get a whole bunch of things happening, the mapping notation really makes life easier. So, okay, state the coordinates of the image of the point -3, 5 under the translation described by that. Okay, so if the original, so the original like xy, and that's going to be turned into, x minus 5, comma, y plus 3. Right, so that's just what we've been given here. And we just want to know where that goes, right? So this is going to be where the image is. So let's actually just put the point in that they gave us now. So this will be an x value of -3, y value of 5, right? Just that point we had there. And that's going to turn into, well, those points, right? So I'm going to put, instead of an x, I'm going to put in -3 minus 5, comma, and then 5 plus 3, and then actually just perform those operations. So that's going to turn into the point -3 minus 5, so -8, comma, 8. Okay. Write the equation of the image, yada, after the translation of this. Okay. So, so in this case, this is saying, right, that every point has moved 2 to the left and 8 down. Yep. It's actually in the equation, so in the mapping notation, it's exactly like it is. It's only the opposite in the equation. So now you're kind of a little ahead of me. So now when we put this thing back in the equation, we have to watch out for the opposite thing. So into the equation, so it's just y is equal to, and then we're just doing the first. Here, we'll do now I won't write the whole thing out. So it's going to be f of x minus h plus k. So this will just be y is equal to f of, and then what's it going to look like? It'll be x. So if it's moving 2 to the left, x plus 2. And then your k value would be -8. So the k is like you would think, and the x is the opposite. But actually, the x isn't even really the opposite when you think about it, because if I'm going 2 to the left, right? If I put a -2 in for h there, then I would be going minus -2, which would be plus 2, right? So it still makes sense, right? Okay, now, these like going backwards ones. So now it says find the original coordinates that gives the following translations. So created the image coordinate -2, 7, right? So now we're just going totally backwards. So we've got the point -2, 7. It was found by using this mapping notation, and it's saying, well, what was your original values of x and y for that point? Okay, so let's write out our mapping notation. Just write that out again. So it's going to be x, point xy, and it's going to be x plus 4, comma, y minus 2. Okay. And we know that these points, right, after I performed this operation, I ended up getting the points -2, 7 out of it, right? So really I'm asking myself, what were those values of x and y before I did that operation? Do you know what they are? Oh, okay. Because you could like kind of just like figure it out from looking at it, but we can make ourselves little equations too, right? So I know that x plus 4 is equal to -2 in the end. And I have to figure out what was x originally. So just a little bit of algebra here. So I'll say x is equal to -2 minus 4. So x must have been equal to -6. And then same thing with a y, right? I can say y minus 2 was equal to 7. So y equal to 9. Okay, so now we can just figure out what our point was. So it's kind of staring us in the face here. So you can say therefore. You guys have seen that little symbol before, right? 3 dots just means therefore. So therefore, the point should have been at -6, 9. All right. Describe the translation that has been applied to the graph of f of x to obtain the graph of g of x. Very common question here. So it says determine the equation of the translated function in our new form. And then lastly, write the mapping notation for the transformations. So we're saying what happened to the blue one to get the red one? Like, what did we do? We went how many up? Yeah, can you see that? Like we went like a good place, especially on these absolute value functions, is to like look at the bottom because they really are hard to tell too, like where that point goes. It seems like I can't tell because this one hasn't been stretched or anything, but the best point to look at on these ones is right at the origin there. Okay, so it goes up 6 and it looks like it goes over 4. Okay, so I'll say it has a vertical translation of 6 up. But this is for you. So if you want to say vertical translation of +6 or something like that, with it, like this is you trying to keep track of everything as we go. So okay, and it has a horizontal translation of 4 right. Okay, so knowing that, let's just write out our equations. So if we started off with y is equal to f of x minus h plus k, we're just kind of filling in the h and the k now, right? So y is equal to f of x, what should it be? If it was going to the right, plus or minus? Yeah, minus. Yeah, so minus 4. And then plus or minus plus 6. Yeah, there you go. There's our equation. And then the mapping notation. So there's our equation. And then the mapping notation here, we're going to say the point x, y, so any generic point on the original graph, is going to turn into, and then what would it be? It'd be x, what's happening to the x's? X plus 4, good. And then y plus 6. This is probably the most common place where people get confused about what's happening here, is they confuse, when to go plus and when to go minus, right? So it's the, like your x value is only the opposite of what you think in the equation. So for your mapping notation, it's exactly what you're doing, right? So if we went 6 up in the mapping notation, you're going 6 up. If we went 4 to the right in the mapping notation, you're going 4 to the right. So it's only backwards in the equation, okay? Okay. So B. You know what? This one's very similar. I just think for time's sake, let's skip down to the next one where we have to draw it. So it says, sketch the graph of y minus 2 is equal to absolute value of x plus 5. State the domain and range of the original and transformed function, and then complete the mapping notation. Okay, so what's happening? Let's do this again where we just say, okay, what's the horizontal translation? What's the vertical translation? So this thing has let's do vertical translation first. So vertical translation of what? 2, yeah, good, yeah, 2 positive or 2 up. and a horizontal translation of 5 left. Good. Okay, so good. That kind of grounds us, right? Now we kind of know what we're doing here, right? So now, okay, so what we have to do is sketch the original here first. Let's see if I can make a straight line. Not sure if this will work or not. No. No. Okay, that does erase. Okay, I'm just going to try it freehand. Okay, so what I'm drawing right now is just the base, the function of this thing. So I'm looking at it after it's been transformed, but what we're relating this to is the function y is equal to, or I'll say f of x is equal to the absolute value of x, right? Because the transformations that we're doing to it are being transformed on this, right? So I'm going to draw just the basic absolute value of x first. So I just drew the one side there, and then the other side there, okay? Now we just have to do these things, right? So we figured out this thing has to go up 2, it has to go 5 left. Let's start with our origin. So that point right there, that's going to go 2 up and 5 to the left. So it should be right there. And I could do the exact same thing, let's say for like this point, and go 2 up, 5 to the left, right? You can do that for every one, but once you kind of get it, you can probably just see how you can draw this thing from there, right? So this thing is going to go same thing. So just up 1 over 1, up 1 over 1 on both sides. Good. Okay, so that's our graph. Now it says we need the domain and range. It says that the original and transformed. Let's just do the transform. So the domain. So our domain. So I'm going to say D for domain. And that will be. I'll do the whole thing. Oh, that was terrible. I'll say X such that X is a member of the real numbers. But really the important bit is just it can be anything, right? X is a member of the real numbers part. Okay, and our range. So this is the only one that's going to change here, right? So our range is going to be Y such that, and then what's Y going to be? Y would always have to be, yeah, greater than or equal to. Yeah, so greater than or equal to 2. And then the full thing, I guess, would be where Y is a member of the real numbers. But again, typically you just write Y is greater than 2, and that's fine. All right, mapping notation. So the mapping notation here is going to be X, Y, and it's going to turn into the point, and then exactly as it is, right? What's actually happening to the graph here. So that's going to be X minus 5 and Y plus 2. All right, last one for this lesson anyway. All right, so if only a vertical translation is applied to y is equal to the square root of x, or, just over here, y is equal to just f of x, so it looks more like our equation here. So y is equal to the square root of x. What would it be if the image graph contains the point 97? Okay, so the key here is that if only a vertical translations happen, that means that, so far what we've looked at is y is equal to f of x minus h plus k. Is that it's only the k value, right? I know nothing happened to the h value. It didn't translate left and right, so I'm only going to worry about the k value. So it's really y is equal to f of just x plus k. And the f of x was the function they gave us there. So y is equal to the square root of x plus k. All right, so this is what's happening. Now, we're wondering what the equation was. What would the, what would the value of k be, or what would the equation be? Now, how can we solve for k?
we could solve for square root of x normally, or without the translation.
Yeah. I
And
think
then, I'm trying to explain this. Never mind.
I think you're on the right track.
Yeah.
I'm gonna do kind of the same thing you're thinking of, I think here, but it's gonna be easier than we think. I could solve for k if I just had some value of y and some value of x, right? If I actually knew what those numbers were, then I could just do a little algebra and solve for it, right? Well, luckily, they gave us a value of x and a value of y, right? I know that those are points on this graph. So we're gonna put those in. So we're gonna say, okay, instead of a y there, I'm gonna put in 7. So 7 is equal to the square root of 9 plus k. So 7 is equal to square root of 9 is 3 plus k. So k must be equal to 4. Yeah. So then, yeah, we can say we know that there's going to be a vertical translation. So vertical translation of 4 up, right? And the equation in the end there would have been y is equal to the square root of x plus 4.